Hello everyone, myself Swapnil Sir and welcome to yet another video on our channel. So already we have started lecture series on coordinate geometry. Within that we have learned plenty of the topics with their proofs. So in our today's video I'm going to explain to you all some of the important results from the coordinate geometry, and at the end we go for solving some of the questions. As the SPI exam it is coming, so I'm planning here to solve some of the PYQs from our lecture. Okay, so let's dive into our today's lecture. First of all, we're going to understand some of the basic concept, and at the end we go for solving some previous year questions from SPI exam, and along with some of the important question that maybe it's a probable chance that it comes for your exam. Okay, now let's get start our today's lecture with the coordinate geometry. Okay, so this one is our third lecture. Okay, now actually what is mean by coordinate geometry? All you have learned about the x-axis, y-axis, plotting the point on a x-axis, y-axis, for finding the measurement between 2 points, for finding the distance between 2 points, whether the 2 points are equal in distance or maybe they are having some unequal distance between them. So in such a case, whenever we have triangle, for finding their centroid, the distance between 2 points, in such a case, we have to understand coordinate geometry well. Okay. Now, within a coordinate geometry, that means we have to learn all these concepts in our x-axis, y-axis for finding their measurement. Like we have to use a distance formula between 2 points. Again, we have to use centroid formula for finding the centroid of our triangle, or we have to use like a area of a triangle, such a formulas. After that, section formula, midpoint formula, all these are very much important here in our today's lecture. So let's get start with the one point that I will explain to you all concept and the formula itself here. Okay, so as I want here in our coordinate geometry, we know that we can define the point. We can define here the point. Yes. So consider this one is the x-axis, this one is the x-axis, and this one is the y-axis. Okay. Now in our x-axis and y-axis, the dividation of a point, that means positive numbers, negative numbers on our x-axis, positive number, negative number on our y-axis, we have to take care all of them here. Okay. Now see that we already know that this one always represent as the origin. Okay. This point always represent as the origin. So this one is the axis, we consider it as the y-axis, and this one is the x-axis, the number which we take from the real line. Okay, so we can see that all the numbers which start from 0 here, all the way it goes to the up and down here. Okay, so we can see that these are the infinite numbers, like a number line. So we represent number here in our x-axis and y-axis. Okay, for finding the coordinate like a positive, negative, we define here in our x-axis, y-axis. Now see that if we have 0 point here, we can see this one goes to 1, 2, 3, and so on. Okay, these are the infinite number of points. Just I mention here some of them. Okay, so it starts from 0 all the way it goes to the infinity, 1, 2, 3, and so on, like this. Okay, and similarly other side of the our x-axis we represent as the negative numbers, like a -1, -2, -3, and so on. Okay, these are the positive number here, these are the negative number on our x-axis. Okay, just for the representation of a point like a x positive, x negative, we take the sign for x and y-axis using our coordinate axis. Okay, similarly when we rotate that x-axis with a 90 degree, okay, when we rotate this x-axis as a 90 degree with the anti-clockwise direction, so we get the y-axis. Now see that if these are the positive, after rotation we get this one is also positive 1, after 2, after 3. Okay, these all are the positive numbers, and all the way it's down here, we consider here -1, -2, -3. Okay, this one is the 90 degree rotation. Okay, that's why positive, negative, all is going here. Okay, now see that for checking the sign for our first quadrant, second quadrant, third quadrant, and fourth quadrant, we have to check the values for x and values for y as per the quadrant. Okay. Now, if we want the positive sign or a negative sign, then we have to think about their quadrant. Okay. Now see that x and y coordinate always represented by order pairs. Okay. Now, if we wanted to represent coordinate x and y, we use like this order pair. Okay. Order pair of x and y. Now see that order pair of x, y means the point of x which comes from the x axis and the next point y which comes from the y axis. Okay. Now always remember that of the first point in our x and y coordinate, it is the first point always goes to x axis and second point always goes to y axis. Remember it always. Now see that if we take any point from our x axis in our first quadrant, it gives us the positive sign. Okay. X always goes to the positive here, and y, we can say that y it is also positive. Okay. That means the coordinate for x axis and the coordinate for y axis in our first quadrant, it represent both are the positive. Okay. Now similarly do it for the second, and always remember first coordinate it goes to the x axis and the second coordinate it goes to the y axis. Okay. So take the coordinate very carefully. So in our second quadrant, we can see that the first coordinate for x axis, it is having negative sign. Okay. So first coordinate for x axis, it always goes to the negative, and obviously y it is a positive here. That means in our first quadrant, we have both are the positive sign. In our second quadrant, we have x is a negative, y it is a positive. In a third quadrant, we can say that x it is a negative there, and as well as y it is also negative. Okay. In our third quadrant, we write x and y both are negative here. Okay. In our fourth quadrant, we can say that x it is positive here. Now see that all the numbers which goes from x axis, it gives us the positive sign, and the downside it goes to the negative sign here. Okay. This one is a fourth quadrant. Now see that all the way we have four quadrant here divided as per their sign. Okay. I hope you all have understood representation of a sign like a positive, negative numbers in our x and y axis. Okay. So we are going to solve some of the example, but not right now, at the end of our lecture. Okay. Now let's move for some another concept like a distance formula, midpoint formula, section formula, that we have to understand it here. Okay. Now let's move for the next concept. Okay. So I hope you all have understood here for coordinate geometry, coordinate for our x and y axis. Okay. And the representation of a point, we will see it later. Okay. Now see that first of all, I wanted to explain here one short formula, which is a midpoint formula. Okay. So when we have two coordinate like x, y, for one vertices, another L, M for another vertices. Okay. Now consider these are the two different coordinate. Okay. And for finding the midpoint of that coordinate, we write some specific type of the formula. Okay. Now let's see this formula first. Okay. What we want here, midpoint formula. Midpoint formula. Okay. Okay, midpoint formula. Now see that we define midpoint for any of the line segment. Consider any of the line segment and find out the midpoint. Okay, by using their coordinate. Now see that I consider here one line segment, which is the line segment A to line segment B. Okay, consider this one is the segment. Don't consider it is the line. Okay. So we have segment AB, and I have the point C, which is the middle point. Okay. Point C, which is the middle point, and the A is having coordinate x1, y1, and B, which is having coordinate x2, y2. Okay. So this one is the coordinate for A, this one is the coordinate for B. Now using midpoint formula, I have to find out the coordinate for C. Okay. Like a coordinate for x and coordinate for y. Okay. The midpoint formula, it says that add first coordinate plus second coordinate and divide by 2. Okay, so how can we write the midpoint formula for C? Add first coordinate like a x1, add with the another second coordinate which is a x2 and completely divided by 2. Okay, this one is the first x coordinate for our midpoint C. Similarly, do it for the y coordinate similarly. Now see that y1 plus y2, y1 plus y2, as we have C which divides our line segment internally. Okay, that means we have to take equal ratio, like we have to take the denominator as a 2. Okay, so this one is the midpoint formula for our line segment. Okay, so this one is the midpoint formula for our C. Okay, this is the way for finding the midpoint. Now instead of a 2 point, if you get the 3 points like x1, y1, z1, x2, y2, z2. Okay, so in such a case, what you have to do, you have to write x1 plus x2 by 2, y1 plus y2 by 2 and z1 plus z2 by 2. Okay, it's completely depend on the point. Okay, that's it for our midpoint formula. I hope you all have understood for midpoint formula. After that, with the concept of a midpoint formula, we have one more formula which is a section formula. Okay, a section formula for internal division, section formula for external division. Okay, now let me explain the section formula for internal division, external division. Okay, so when midpoint formula it is applicable and when section formula it is applicable. Okay, now see that our line segment AB which divided by another point C. Okay, which is having equal ratio, this ratio as to this ratio, both are equal. Okay, that's why we use a midpoint formula. But what happen, instead of that equal ratio, we get the one ratio with respect to another ratio, both are different. In such a case, exactly we have to apply section formula. Okay, now let's see the section formula. Okay, so I'm gonna explain here section formula. Okay, now we know that section formula is defined for two particular cases. One it goes to internal division, another one it goes to the external division. Okay, that means we have section formula for two cases. First, section formula for internal division and section formula for external division. Okay, now let me explain what is actually mean by section formula for internal division. Okay, so if we have line segment AB and a third point which divides our line segment AB with a different ratio, okay, with a different ratio, then we consider section formula for internal division. When we consider section formula for internal division, when our line segment divides another third point with the unequal ratios, then we consider it is section formula for internal division. But the case here, that point it has to divide internally. Okay, that is the section formula for internal division. Similarly, we do have section formula for external division. Okay, so what the actually section formula for external division do? When we have third point which divides our line segment AB, but not internally, it divides externally, then we apply section formula for external division. Okay, now let me write the two different cases for section formulas. Okay, different formulas I have taken here in my next slide. Okay, so first let me write for internal division. Okay, this one is the section formula. Okay, section formula. First it is for internal division. Okay, now let me explain with one of the figure here. Okay, so how can we define section formula for internal division? Now see that this one is our line segment AB which divide third point C as a internally. Okay, and let me plot the one triangle which completely lie here on our third line segment AB. Okay, now see that it is considered it is the O point. Okay, See that our line segment AB, which divided by third point C, having equal distance from O. Okay, it is not that necessary it needed equal or not. Okay, it is completely up to this, but we have to remember only here line AC and line segment CB, which divides in the ratio as M as to N. Okay, which divide in the ratio of M as to N. Then section formula for two coordinate. Okay, so let's consider here A is having coordinate x1 y1, B which is having coordinate x2 y2. Okay, now see that which is third point C divides our line segment internally. Okay, now section formula for internal division for x and y coordinate we write here cross multiplication for our ratio of our point with the coordinates. Okay, now see that x1 into N, we write x1 into N. Okay, x1 into N plus x2 into M, x2 into M. Okay, x1 into M plus x2 into M divided by N plus M here. Okay, this one is the first coordinate here. This one is our first coordinate for our section formula. Okay, when third point divides our line segment AB as a C. Okay, now next point we write here same equal opposite ratio we have to take it here. So y1 into N. Okay, we write next coordinate y1 into N plus x2 into M, x2 into M divided by N plus M as a section formula for internal division here. Okay, this one is our internal division. Now consider that this one is for internal division. Consider it for the external division. Okay, when we do have for external division, what we do, we take instead of a positive it is only negative. Okay, now see that I am going to consider here for external division. External division. Okay, so I'm going to consider it for external division. Now see that I'm having one line segment AB here, which third point C divides our line segment AB as a externally. Plot the triangle what it is coming here. Okay, now see that BC which divides point C which divides our line segment AB, but it is externally. Okay, then we apply section formula for external division. Okay, now see that the ratio you may consider x1 y1, x2 y2, C ratio we want it here. Okay, consider this one is M as to N. Okay, then we want the section formula for external division. Now just need to remember here for finding the section formula for external division, instead of these two positive signs we take it negative. Okay, now let me write for the section formula for external division. This one I consider for internal. Now second for external. External means we just have to replace negative only here. Okay, x1 into N minus x2 into M divided by N minus M, comma, next y1 into N minus let me see x1 y1 x2 y2. Okay, yes, x1 into N plus x2 into M, y1 into N plus y2 into M. Okay, so this one is y2 into M divided by N minus M here. Okay, now see that this one is section formula for internal division, this one is the section formula for external division. These formulas are going to very much important for our subsequent example that we see in our next example. Okay, yes, there are some another formulas also, like area of a triangle, centroid of our triangle. Okay, there are so many formulas that I feel that we have to learn this formula while solving the examples. Okay, so we'll see this example while we solve the example. Okay, we see this formula while we solve the example. Okay, now just let me explain one formula, like a centroid formula. Distance formula we'll see it later. Okay, so let's consider here, let me explain first distance formula. Okay, distance formula. Now I'm having segment AB. A is having coordinate x1 y1, B which is having coordinate x2 y2. Okay, So I want the distance between these 2 points, point A to point B. For finding their distance, we always take under square root x2 minus x1, second term minus first term square plus second term minus first term square, y2 minus y1 bracket square. Okay. So this one is the distance formula for our line segment AB when we have two coordinate. But when we have three coordinate, we have to take x2 minus x1 bracket square plus y2 minus y1 bracket square plus z2 minus z1 bracket square. Okay. This one is a formula which is applicable for finding the distance. Okay. So after the distance formula, you all need to know some of the formulas for triangle, like a centroid formula and area of a triangle. Okay, we know that area of a triangle, we know right, it has the 1/2 into base into height. Okay, but that formula we extended here for some of the example. We'll see that formula later. Okay, so centroid formula we add a similar like a distance a midpoint formula. We add their coordinate like x1 plus x2 plus x3 divided by 3, y1 plus y2 plus y3 divided by 3, which is a centroid formula for our triangle. Okay, centroid formula, we know that. What is mean by centroid for our triangle? When we find angle bisector of a triangle, okay, when we find angle bisector of the triangle and the middle intersecting point, we get it here, that we consider it as the centroid. Okay, that one we consider here as the centroid for our triangle. Okay, centroid for our triangle. So for finding the centroid, we add three first vertices divided by 3, and another coordinate we add second all three vertices divided by 3. Okay, let's move for some of the example here. So I have taken some of the example which are very much important for your upcoming exam. So go with the proper preparation with such examples. Okay. Now let's me read the question first. Two of the vertices of a triangle ABC are given. Okay. So what we have here, triangle ABC. Okay, triangle ABC given, which is having two vertices, which is A64, which is having two vertices A64, and the second vertex is B minus 2. Okay, second vertex is B minus 2 here. Okay, so we have two of these vertices and a centroid also given, G of 3, 4. Okay, G of 3, 4, which is also third centroid given, and we have to find out the coordinate of a third vertices. Okay, we have to find out the coordinate for third vertices. Now as we have triangle ABC, point A and point B are given. Okay, that means obviously third point of our triangle, third vertices of our triangle, it should be a point C. Okay, that means we want the value for C of xy. Okay, whenever we have to find out the any value, we consider it as the xy. Okay, C of xy. So we want the third vertices as a C of xy. Okay, now let me plot the figure here. Okay, so once you get some little visualization of our given data, then you are able to solve these examples easily. Okay, okay, so now see that, let me plot the triangle first. So we have this triangle here. Okay, so triangle having vertices A, B and C. Okay, angle bisector of triangle make here as the centroid for our triangle. Okay, so consider this is a G as the centroid. Okay, G of 3, 4, this one is the centroid here. C of xy, we want this point here, C of xy. After that, B of minus 2 to given, minus 2 to these 2 points. A, which is having 6 and 4, are these 2 points. Okay, so coordinate for vertices A, coordinate for vertices B, C and centroid G given. Okay, so I consider point C as a xy because we want the value for xy. Okay, and let's go for finding the value for xy. As we know that the centroid of a triangle can be written as addition for 3 vertices divided by 3. Okay, let me write the formula first. So we know that centroid of our triangle, okay, centroid of triangle ABC can be, or any general formula. Let me explain first of all general formula. Okay, so if we have a of x1 y1, b of x2 y2, c of x3 y3, and we want the centroid of our triangle as a g. Okay, so we write g of xy as a centroid, which is equal to, we take the addition for all these three vertices, x1 plus x2 plus x3. Okay, so x1 plus x2 plus x3 divided by 3. Okay, this one is the first coordinate for our centroid. And similarly, y1 plus y2 plus y3 divided by 3. This one is our second coordinate. Okay, now see that this one is y1, y2, and this one is a y3. Okay, so using all this data, we have to find out the value for third coordinate c of xy here. Okay, now let's go for substitution of the values. Okay, so g of xy can be written as addition of all x1 plus x2 plus x3. Okay, that means 6 plus minus 2 plus x. Okay, 6 plus minus 2, 6 plus minus 2 plus x divided by 3. Okay, that means first addition for first coordinate, 6 plus minus 2 plus x divided by 3. Similarly for y coordinate, 4 plus 2 plus y divided by 3. Okay, this one is the next coordinate here. Yes, go for finding their addition. As we have centroid also given, g of 3 4. Okay, put this value here. So we write g of 3 4, which is equal to addition of these vertices, 6 minus 2, which is a 4 plus x. Okay, so 4 plus x divided by 3. Okay, and a 4 plus 2, which is a 6. That means 6 plus y divided by 3. This is the next vertices. Okay, now see that when we have xy coordinate with the another xy coordinate, both coordinates are equal. Now let me explain here. If I consider a of x1 y1, which is equal to b of x2 y2. Okay, so if I consider these two order pair of our coordinates are equal. Okay, if these two are equal, then we write first x coordinate equal to second x coordinate, and first y coordinate equal to second y coordinate. Okay, so we write x1 which is equal to x2. So we write using both of these equality, x1 which is equal to x2, and second y1 which is equal to y2 here. Okay, we write this one, x1 which is equal to x2 and y1 which is equal to y2 here. Okay, so similarly define it, 3 which is equal to 4 plus x by 3. Okay, so we write 3 which is equal to 4 plus x divided by 3. First coordinate equate with the first and second coordinate with the second. 4 which is equal to 6 plus y divided by 3 here. Okay, now find out the value for x using this one, and find out the value for y using this one. Okay, so this one should be your final answer. Okay, yes, then first we write x which is equal to 3 3s are 9 minus 4. Okay, 9 minus 4, then x coordinate we write it as the 5 here. Okay, so I got the value for x which is a 5. Similarly do it for the value of y. So y can be written as y which is equal to 3 4s are 12 minus 6. Okay, then y we can write it as the 6 here. Okay, so the coordinate for point x and y we consider here, which gives us the value 5 and 6. Okay, this one is our C coordinate, which is a 5 and 6. Now see that in our option number D, which we have given, 5 and 6 are the coordinate here. Okay, now let's move for the next example. Okay, so in our next example, we have to find out the value of a P for which the point minus 1 3, 2P and a 5 minus 1 are collinear. Okay, yes, so we have to find out the value for point P which these 3 points are collinear. Okay, so we do have the condition for collinearity. Okay, condition for collinearity. First of all, understand the meaning of a collinear point. Okay, so what is actually mean by collinear point? The collinear point, it defined as the point which along with the another point or the point which parallel to the another point. Okay. Now what mean by collinear point? Let me explain first. Collinear point. Okay. So what is the collinear point? When we consider 3 points are collinear, now see that this one is the first, this one is second and third point. Okay. Now see that point A, point B and point C, these are the collinear point. Why they are collinear? Because they are along with each other. Okay. That means whenever we have a long point like a line segment AB along with the line segment BC, then we write it as the collinear line or collinear point. Okay. This one is the first condition. And second condition, we write line segment AB which is a parallel to line segment BC. Okay. When we have parallel line, then we consider it as the collinear point. Okay. Now see that we have the point P. Okay. That we have to find it here. And the vertices is also given -1, 3, 2 P and 5 -1. Okay. Now just think little bit logically here. When we have 3 points, okay, when we have 3 points, they are collinear. Okay. The 3 points, if they are collinear, can we plot or can we draw triangle using collinear points? Never possible, because for plotting triangle we need non-parallel line. Okay. Now see that it is not possible to plot the point using collinear point. Okay. So how the triangle define? Now see that this one is the triangle. Now see that if the line intersect each other, then it is not the collinear point. Okay. Now see that we cannot form the triangle using collinear point. Okay. That means if we cannot find our triangle using collinear point, then obviously we write area of a triangle, it is always 0. Why we write area of a triangle 0? Because there exists a collinear point. Okay. That means we write here area of a triangle which is equal to always 0. Okay. Area of a triangle which always 0. Okay. And we write area of a triangle as 1/2 under bracket. Okay. We write area of a triangle it as 1/2 x1 under bracket y2 minus y3 x1 under bracket y2 minus y3 plus x2 under bracket y3 minus y1 x2 under bracket y3 minus y1 plus x3 under bracket y1 minus y2. Okay. y1 minus y2. Okay. This one is the area of a triangle. Area of a triangle. Okay. And which we know that if the points are collinear, that means area of a triangle always goes to 0. Okay. That means this point, it goes to 0 here. Okay. So area of a triangle is 0. That means all these points are goes to 0 here. Okay. Yes. So now see, we have here the points -1, 3. Okay. This one is a x1. This one is a y1. -1 which is equal to x1. y1 is equal to 3. x2 which is equal to 2. And y2 which is equal to p. x3 which is equal to 5. And y3 which is equal to -1. Okay. Put all these values in our result, you will get the area of a triangle. Okay. Now see that if this entire value it goes to 0, that means that 2 it is also going 0, because 2 is the denominator here. Okay. And when we take it to the other side, it goes to 0. So leftover term here we write x1 under bracket y2 minus y3 plus x2 under bracket y3 minus y1 plus x3 under bracket y1 minus y2, which is equal to 0 here. Okay. This one is our area of a triangle. Okay, I modify our area of a triangle this way. Okay, now put the value for x1, y1, x2, y2 and x3, y3 in our result. We will get the required value for P. Okay, so what is the value for x1, which is a -1, y2 minus y3. Now P minus -1, that means P plus 1 here. Okay, y2 minus y3 means y2 which is equal to P. Okay, minus y3 means minus of -1, which is +1, plus x2. What is the value for x2, which is a 2, and y3 minus y1. y3 which is y3 -1 -3. Okay, so -1 -3, y3 minus y1 -1 -3, plus x3 which is a 5 under bracket y1 minus y2 here. Okay, so y1 3 minus p. Okay, 3 minus p, which is equal to 0. Now observe our area of a triangle. It seems like that it is only the involvement of a term p here. Okay, and whenever we have single constant present in our equation, that means easily we can find the answer for that constant. Okay, now see that I am having p here. Let's go for finding the value of a p. So -1 into p, we write minus p. -1 into +1, we write -1. 2 into -1, we write -2. 2 into -3, we write -6. Okay, after that 5 into 3, we write 15. 5 into -p, we write -5p. Okay, which is equal to 0. So -p minus 5p, we write -6 times p. -1, -2, -3, -6, we write a -9. -9 plus 15. Okay, so we get the plus -9 plus 15. That means 15 minus 9, we get the 6, which is equal to 0. Okay, that means -6p plus 6, which is equal to 0. What is the next step? -6p, which is equal to -6 here. Okay, -6p, which is equal to -6. Now let me see what we have done here. -6p, which is equal to minus of 6. Okay, so is it negative c minus p? Yes, minus 5 3s are 15. Okay, so -6 plus 15. So we get the positive 6 here. Okay, is there anything sign convention remain? -5 minus 1. Okay, -6p plus 6, which is equal to 0. Now see that -6p, which is equal to -6, we write a 6p, which is equal to 6, then p, which is equal to 1 here. Okay, this one is our required answer. Now as we have correct answer over here. Okay, now see that we want the value of a p by using our required data, and then I got the value for p, which is a 1, given in our option number D here. Okay, so our correct option D, which is true here. Okay, let's move for the next example. Find the distance of a point -6, 8 from the origin. Okay, so we have to find out the distance of a point from the origin, and as we know that the point from origin means the coordinate for origin we have 0 0. Okay, and we have to find out the distance of a point. Okay, now consider this one is the origin and this one is the distance for another point -6, 8. Okay, and first point with 0 0 8 is 0. Okay, and we have to find out the distance of that origin O to point. Consider this one is a P. Okay, so we have to find out the distance of a point from the origin to point P here. Okay, so point O to point P, we write a distance by using distance formula. Okay, distance formula we write coordinate between two coordinates. If we have to find out the distance, we write x2 minus x1 bracket square plus y2 minus y1 bracket square. Okay, this one is distance formula. Now see that consider x1 y1, x2 y2. Okay, substitute all these values here. So we write x2 minus x1. So -6 minus 0, -6 minus 0. Okay, bracket square plus y2 minus y1, 8 minus 0. bracket square. Okay, so we write this one as the minus 6 square plus 8 bracket square. Okay, this one. And after that we write 6 square it is a 36 plus 8 square it is a 64. Okay, so complete addition for these two terms we write square root of 100. Okay, and square root of 100 which is a 10 here. Now see that in our option number C, which we have given required answer. Okay, the distance from origin to point minus 6 8 which is a 10 here. Okay, yes, I hope you all have understood. Now let's move for the next example. So in our next example, we have to find out the value of a p for which point minus 5 1 1 p and 4 minus 2 are collinear. Okay, similar condition again we have to apply. If the 3 points are collinear, that means we cannot draw the triangle there. Okay, if the 3 points are collinear, that means we cannot plot the triangle, and if triangle it is not there, that means area of a triangle always goes to 0. You may use this result also. Now see that for solving single question in our mathematics, we have several type of the methods. Okay, and all method gives you equal and exact answer. Okay, so it is completely up to you which method you felt comfortable for solving the answer. Okay, yes. Okay, we know that if the 3 points are collinear, then we write the area of a triangle are 0. Now let me write the definition, main point here. If 3 points, if 3 points are collinear, then area of triangle is 0. Okay, then we write area of a triangle which always goes to 0. Okay, yes. So if area of a triangle it goes to 0, that means we write 1/2 into, okay, 1/2 into x1. Okay, first of all write down the basic way, write down the x1 here plus x2 here plus x3 here and another bracket. Okay, and then complete the bracket. Okay, so as we have x1, then next step we have to take another that means y2 minus next step as the y3. If x2 is there, then y3 minus y2. Okay, and sorry, y3 minus y1 here. Okay, y3 minus y1. If x3 it is there, then we write y1 minus y2 here. Okay, and if area of a triangle it goes to 0, that means this entire value it goes to 0. Okay, then put the all value. We have x1 here as a minus 5, y1 here as the 1. Okay, compare x1 y1 x2 y2 x3 y3. Okay, x2 which is equal to 1, y2 which is equal to p. Okay, x2 1 y2 p, x3 which is equal to 4 and y3 which is equal to minus 2 here. Okay, x1 y1 x2 y2 and x3 y3, we do have 3 points here. Now substitute all these values here. That 1/2, if we take it here, if we take that 1/2 here, it comes to be the new multiplicand for 0, and 0 multiplied by any term always goes to 0. Now substitute the value for x1 which is a minus 5 under bracket y2 minus y3. So y2 minus y3, we have p minus 2, that means p plus 2 plus x2. What is the value for x2 which is 1, y3 minus y1 minus 2 minus 1 minus 2 minus 1. After that we have positive here plus x3. What is the value for x3 which is a 4 under bracket y1 minus y2. So 1 minus p here. Okay, which is equal to 0. Now let's go for multiplication under bracket minus 5p minus 5 2s are 10 plus minus 2. Okay, so we take it negative here. Okay, so plus 1 into minus 2, we write minus 2 here. After that 1 into minus 1, we write minus 1 here. Okay, yes, plus 4 into 1, we write 4. 4 into minus p, we write minus 4p, which is equal to 0. Okay, so minus 5p minus 4p, we write minus 9p. Okay, so minus 10 minus 2 minus 12 minus 1 minus 13, minus 13 plus 4, which we write minus 9. Okay, minus 9, which is equal to 0. So take all the terms to the other side. So minus 9p we write, which is equal to 9. Okay, then p we get it here 1. Okay, this is the value for p, which is a negative 1, not 1. Okay, p which is equal to negative 1. Now see that in our option number D, we have given p which is equal to negative of 1. Okay, that is the required answer for our given example. Now let's move for the next example. In our next example, we have given find the value of a k if the point 2, 3, 4k and 6 minus 3 are collinear. Okay, so we have given 3 of these points and we have to find out the value for k here. Okay, so what we have, first point 2, 3, again 4k and 6 minus 3. Okay, these 3 points are given and we have to find out the value for k here. Okay, yes. Now see that for finding the value for k using our given data, we already applied here the condition for area of a triangle. Okay, it goes to the 0, and then we substitute all the values in our formula. Okay, and then we got the required answer. Okay, using our given data. Okay, now similarly we have to follow it here for this example. Take the area of a triangle 0 and substitute the values. Okay, take the area of a triangle 0 and substitute the value, then you will get the required value for k. So we know that area of a triangle, it always goes to 0 when points are collinear. Then let me write the formula for area of a triangle, which 1/2 x1 plus x2 plus x3, which is equal to 0. Okay, it goes to 0. So x1 under bracket we write y2 minus y3, x2 under bracket y3 minus y1. Okay, and x3 under bracket y1 minus y2 here. Okay, so this it goes to 0. Substitute the value for x1, y1, x2, y2, x3, y3. This one is x1, this one is y1, x2, y2, x3, y3. All this value for x1, x2, x3, y1, y2, y3 we do have here. Substitute all the values here. So we get the x1 we have here 2 under bracket y2 minus y3. So k minus minus 3, that means k plus 3 plus x2, which is a 4 under bracket y3 minus y1. y3 minus y1 means minus 3 minus 3 minus 3 minus 3 plus x3. We have 6 under bracket y1 minus y2. So 3 minus k. Okay, 3 minus k, which is equal to 0 here. Okay, this one which is equal to 0. Now after finding the calculation, you will land on the value for k which is equal to 0. I'm not gonna find the value for k here, so you have to go for the calculation later on. So this one is an entire easy solution. Do not nothing is difficult here. Similar type of the questions are coming to your SPI exam, so be sure about this example, prepare it properly, follow these formulas, and you will get the good marks for this type of the examples. Okay, so very easy type of these questions, just need to understand some of the basic concept. Okay, I hope you all have understood this solution. Let's move for the next example. In our next example, we have given in what ratio line x minus y minus 2, which is equal to 0, divides line segment joining 3 minus 1 and 8 and 9 here. Okay, so we have given the example where the line gives x minus y minus 2, which is equal to 0. Okay, so we have given line x minus y minus 2 which is equal to 0, and divides line segment joining, we have line segment joining the 2 points 3 minus 1 and 8 and 9. Okay, this one is the first point for our line, this one is the second point for our line, and we have to find out the line segment joining these 2 points which satisfy our given equation. So as we know that this example completely based on the section formula. Okay, this example completely based on the section formula. That let's see which section formula is applicable for internal division or external division. We'll see it here. Now let's go for finding the section formula for internal and external division. So as we know that we don't have the ratio for our section formula. Okay, for finding the ratio for our points, we don't have the ratio given, that we have to find here. Okay, so we see that point first, second, third, fourth, we want the value for point first, second, third, fourth. Okay, so these 4 points are given in the form of m as to n. Okay, so we have to find out the value for m and we have to find out the value for n over here. Okay, now let's consider this point m and this one is the n here, and then we go for finding the section formula. Okay, using the section formula for value of m and n. Let's go for finding this using section formula. So 3 into n plus 8 into m. 3 into n plus 8 into m upon n plus m, which is the first coordinate, and the second we have 9 into m, 9 into m, 9 into m minus 1 into n, minus 1 into n divided by m plus n or n plus m, you can take it anything. Okay, now see that we have the coordinate for our midpoint. We have the coordinate here for that third vertices which divides our line segment internally. Substitute this point x and y in our equation x minus y minus 2 which is equal to 0. But why we do have to substitute this coordinate x and y in our equation? Because this coordinate for x and y which lies in our line, and when we have two coordinates which lies in our line, that means these coordinates are the solution of our given line here. So that means if we substitute this coordinate in our given line, we will get the required solution for our line. Now let's substitute the value for these two coordinates in our line. So x minus y, so this one is the value for x, this one is the value for y here. Substitute both the value. So x minus y means 3n plus 8m upon n plus m. After that minus of y means second coordinate. So 9m minus n upon m plus n here. Yes, and a minus of 2 which is equal to 0. Take that denominator to the other side, so we get it is 0. So 3n plus 8m minus 9m plus n minus 2m minus 2n, okay, which is equal to 0. So what I have done here, basically I just multiplied n plus m throughout this term. So n plus m multiplied by this one, cancel denominator, also it cancel denominator, but n plus m or m plus n is the multiplicand for minus 2. So I return this minus 2m minus 2n. Let's go for finding the value for m and n. So we will get the required ratio for our line segment which divides our point internally. Okay. Now 3n plus n. So 3n plus n, 4n minus 2n. We write 2n here. 8m minus 9m. So minus m minus 2m. We write minus 3m which is equal to 0. So 2n which is equal to 3m. Okay. So we write a 2 by 3 which is equal to m divided by n. So our ratio m as to n defined as 2 as to 3. m as to n defined as the 2 as to 3, our required answer. Now see that in our option number B, we have given 2 as to 3 our required answer here. Okay, I hope you all have understood this solution. It's completely easy solution based on section formula for internal division. Now let's move for the next example. In our next example, we have given find the ratio in which the line segment joining the point 641 minus 7 is divided by x axis. Okay, is divided by x axis. Now first of all, we have to apply section formula for internal division in our example. Why we have to apply? Because our point which divides our line segment, okay, in the ratio, we have given ratio here, and a line segment having two coordinates, which is a 6 4 first coordinate for this line segment, and the second, consider 1 minus 7, which is the second coordinate here. And as we don't know the point which divides our line segment internally and the ratio, so consider the ratio as a k as to 1. So if we don't know the ratio of these 2 points are equal or not equal, if the ratio equal, apply midpoint formula. If the ratio are not equal, obviously both are different. So consider one of it is 1 and another it is some constant k. And using this one, find out the coordinate for x and y. So what we will get the section formula for internal division. What we need to apply here? Section formula. Internal division. So we have to apply as a section formula for internal division here. So we write 6 into 1 plus 1 into k, 1 into k, okay, divided by k plus 1 is the first coordinate for our section formula. Second, by using section formula, similarly minus 7 into k plus 1 into 4, which is remain 4 upon k plus 1 is our second coordinate here. Okay, and as we have given the ratio of the line segment that we want here, which divided by x axis, Now, when any ratio or any point which divides our x axis, that means we get the y coordinate always 0 here. That means this coordinate goes to 0. So minus 7k plus 4 upon k plus 1, it goes to 0. That means minus 7k plus 4, it goes to 0. That means 7k, it goes to 4. And then value for k, which gives us 4 by 7 here. Value for k, which gives us 4 by 7. And what we want the ratio for our point k and 1, which divides our line segment internally. Okay, that means k, we have the point which divides k as to 1, that means 4 by 7 as to 1, that means 4 as to 7 here. Okay, this one is our required 4 as to 7 as the section for our internal division. Okay, this one is the ratio which divides our third point internally, is a 4 as to 7 here. So this one is our required answer in our example. Now see that how easy type of the questions are, that we have to understand when the point which divide x axis, that means we have the equation of x axis which is the y which is equal to 0, that we have to apply section formula for internal division, that one we have to apply here. I hope you all have understood. It's completely easy solution. Now let's move for the next example. Yes, in our next example we have given here which point lies on x-axis. Very easy question. The example completely based on the coordinate for x and y. Okay, so we have given which point lies on x-axis. We know that first quadrant having both positive, second quadrant having negative positive, third quadrant negative negative, fourth quadrant negative positive, positive negative here. Okay, third coordinate x is positive, y is negative here. Now see that if the point which lies on a x-axis, that means we want one of the coordinate which is a 0. Okay, the point which lies on a x-axis means we have y0. Always remember, when any point which lies on a x-axis, that means the another coordinate for y-axis always 0. Okay, so if the point lies on a y-axis, that means obviously x which is equal to 0. Now point lie on a x-axis, that means y0. Now observe that here it is y0. In our option not given, this one it is not given, this one it is not given. So in our option C, 2 0 which given y which is equal to 0. Now let's verify with the plotting figure. Okay, 2 0, that means x to 1 consider here, 2 consider here. So this one is a straight line which represent point 2 0. Okay, so see that we have y0, so we given the point which lie on a x-axis which is the 2 0. Let's move for the next example. Point which lies on a y-axis, that means point if lies on a y-axis, that means always x goes to 0. So see that in our option C, x is a 0, that means this one is 1, this one is a 2. So this one is our required answer, 0 2 which lies on a y-axis. So if you are going to plot the remaining point, they cannot lie only on y-axis. Okay, they are the part of x-axis too. So that's why we don't have to take another point. Only 0 2 is our required answer. Okay, I hope you all have understood this solution. Now, which graph is parallel to x-axis? Now see that we have to find out the graph for our points. Now let me plot the line here. This one is the y-axis, this one is the x-axis. We want the graph which is a parallel to x-axis. So parallel to x-axis, these types of the lines are here always. These are the lines which parallel to our x-axis here. Okay, now see that if I'm going to plot y which is equal to 2, so this one consider 1 and this one is a 2. Okay, so we see that this one line y which is equal to 2 here, this one is the x-axis, this one is a y which is equal to 2 here. Now obviously these two lines are parallel to each other. So our option number B, which gives us the line which parallel to x-axis. So remaining line, you can see that x which is equal to 3 which is perpendicular to x-axis, x which is equal to 2y which goes to like this one, this way. Okay, that means this is also crossing x-axis, not the parallel. And if x and y coordinate present, that means the line which passes through x-axis and y-axis. Okay, that means our required answer for this example, the graph which parallel to x-axis, which is a y which is equal to 2 here. Okay, I hope you all have understood this solution. Okay, that's it for our today's lecture. So I'm going to explain to you all now what we have learned so far in our today's lecture. We started with the coordinate geometry, with some of the basic concept from coordinate geometry. So then we learn here the section formula. After that, midpoint formula. After that, we learn here distance formula. After that, we learn here the point on our x-axis, y-axis, how to present the coordinate, how to plot the coordinate, quadrant-wise positive, negative sign. All these concepts and so many other concepts we learn in our today's lecture. So I hope you all have understood my today's lecture. So if you like this video, just let me know in my comment section. This one will be the really big motivation for me. I'm expecting that you all have understood everything from my today's lecture. If you wanted to see similar videos like my today's video, do check in my playlist. You will get the plenty of the videos there. So thank you everyone. Thank you for my today's lecture.